problem solving through programming in C tutorial session. Mm. Hi everyone, am I audible? Please confirm by tapping in the chat box. Mm. Great. So let's wait for a few more minutes so that others can join and then we'll start the session. Hi everyone, just please confirm that I'm audible and my screen is visible. Fine. Mhm. Is my screen visible? Anyone, please confirm. Fine. At any time step, if you observe that my screen is not visible, please tell me at that time only. Fine. Let me join this from one of more devices. So let's start this session. So the way we'll be conducting this session is I have some practice problems for you guys that I'll be solving for you guys in this session, and you can ask queries regarding any doubts you have for any topic that has been covered till today, uh, and the problems that I'm discussing right now. The way you will be communicating with me is via the chat box. So you have to use the chat box to communicate with me. So if you have face any difficulty or if you have any queries related to any problems, type in the chat box at that instant only. If at any instant you find out that my network is not working or my voice is not audible or my screen share is not visible, then type in the chat box at that instant only. Fine, everyone. Do you have any doubts? Are the instructions clear? Please confirm by typing in the chat box. Great. So let's start the session. So I'm Rupesh Kumar, and this is a eighth tutorial session on problem solving through programming in C. So in this week, you must have learned about functions, so writing functions in the C programming languages, the C programming language. So I have few problems for you guys. So let's solve these problems. Fine. So let's move on to the first question. So what is the default return type if it is not specified in the function definition? So let's say I am declaring a function, and some data type, some arguments into this. Let's say integer argument. Let's call a character argument char a, and the function is doing some operation. So what is the return type? Default return type? Anyone? So the default return type would be integer. So if you do not specify any return type here, so I have not specified any type return type here. So in that case, GCC compiler will by default assume that the return type is integer. Fine. Fine. Anyone, do you have any doubts in this problem? I guess no one has any doubts. Fine. So let's move on to the next question. Yeah, someone is typing something. Fine. So let's move on to the next question. So we have two functions in the same file. So everyone, is the code visible? Can you see the code? So let's say in our C program, we have written this program. Hmm. So we have this main function. So at the first line, we are including the standard IO library. And then we have declared a function prototype. So everyone, are you familiar with this idea of function prototypes? Where how we what are function prototypes and how we are using it? It's a function prototype. Everyone, are you familiar with this concept of function prototyping? Hello, am I audible? Huh. So what are function prototypes? Basically, function prototypes are statements like this that define the return type of function, the function name, and the arguments that we are passing to it. And why do we need this? We need these function prototypes in cases where our functions are in different separate set of files, or our function is our code is organized in such a manner that the main function is present before the declaration of the function declaration. So for example, in this case, the function factorial with a return of an integer, and that takes one integer or variable as an argument, has not been declared here. We are just telling the compiler that there is some function with this prototype, and feel free to call this function using this send this function name and passing one single integer argument, and the declaration will be followed after somewhere in the program. Fine. The compiler links with these declarations later on. Fine. So now our main function begins. It has a return type of integer, and inside the main function, we can see we have declared an integer variable n, int n equals to 5. Then we are declaring a long integer f. So basically, are you from? I hope every one of you is familiar by these basics data types. So long integer is a data type that is used to hold integer values of larger integer values. So basically, these values are bigger than what the classic integer data type can hold. Fine. So we have long integer f. Now we are assigning the value returned by the function factorial over n in the function f to the variable f. Fine. So we are saying f equals to factorial n. Fine. So now what we are doing, we are printing the value of n and f using this printf statement and then return 0. So our program exits. So now let's go and see what the factorial function is doing. Fine. So every one of you, are you familiar with the concept of factorials? So what is the meaning of factorial? Let's say if I say factorial 2. Factorial 2 is 1 multiplied by 2. So basically for any given integer, factorial n is equals to 1 into 2 into 3. And you keep multiplying these integers until you reach the variable value n. Fine. So this is a definition of factorial, and this function basically implements this functionality. So let's go ahead and see this factorial function. So we see int factorial. So we were not, so we already saw the prototype for this function in the just before the main function. It says it has a return type of integer. The function name is factorial, and it takes in one integer argument. Fine. So let's see. So this function declaration follows that same prototype. So it is perfectly fine. Now let's see what happens inside the function. So if n equals to 0, we have to return 1, else we have to return n into factorial n minus 1. Fine. So before solving this problem, are you familiar with the idea of recursive functions, everyone? Please tell me if you are familiar with the idea of recursive functions. I hope you all have gone through the video lectures, but still I want to ask. Anyone do you have any doubts with the recursive functions? Please type in the chat box. Fine. So what are recursive functions? So we have solved this problem using recursion. Using recursion in programming. So a function is called a recursive function when it calls itself for the for execution. So how does this function look like? So we have a function, some return type, then function name. So let's say this is a basic syntax of a recursive function. Then we have function name, and then you take arguments. And inside the function, there are three basic structures that are required. First one is the base case. If base case condition, some base case condition, return some value, fine. So exit the program. So basically what this means, exit the program. Else, so we have this recursive case. This is a basic idea. Call the function again. Function again with a new value. Fine. So let's call the function again, function name, and let's say arguments plus one, something like this. Okay. Fine. This is how the how recursive case. So this is how we use recursion in programming. So we can use it with recurrence problems that require recurrence or series problems. Fine. So there are few things that needs to be taken care of in these programs. Is you should be aware, your program should contain the base case. The base case is very important, and your program should ensure that the recursive case eventually leads to the base case conditions. If it does not, anyone, can you tell me what happens if let's say your program does, recursive function does not have any base case, or your other non-recursive or your recursive cases, recursive calls does not lead to the base case, then what happens? Anyone, can you tell me? So this is a basic problem on how functions work. So, anyone, can you tell me what happens? So no one is familiar with the idea of recursive functions? Why these recursive cases are required? Am I audible? Is my screen visible? Anyone? Please confirm by tapping in the chat box. Is my screen visible? I think there is some network issue. Hello, am I audible? Anyone? My screen is also visible, no? Great. So where were we? I was asking like what are recursive functions? So I gave it some idea like recursive functions are function with that is a statement that calls the function itself again and again with inside the function. Then we saw that our recursive function must have two different sets of cases. One is a base case and the second one is the recursive case. And your program should ensure that the recursive case eventually leads to the base case condition being true. So there are two questions here. Why do we really need the base case? The second thing, why should the non-base, basically the recursive case lead to the base case condition? Anyone, please answer. If you have gone through the lectures, you should be able to solve answer these questions. Yeah. So without the base case condition, the function won't stop calling itself again and again. So let's see what happens. So, so let's say we have some function. Huh. So let's say we have some function here. We have some function here. So what happens whenever a function call is made in the main program? So there is a stack space associated for the in the program memory, in the main memory, whenever a program runs. And whenever a function call is created, whenever we have a function call, then what happens? This is the stack space, fine. So whenever you call a function in your C program, what happens? The function, the reference to the function is stored into this stack, fine. And this stack has a specified set of fixed memories depending upon the hardware. Now, if you're calling the function again and again, so it gets filled up very quickly. So let's say you call this function again from this function, so it gets stored here. Then again, this block gets filled and here and here. And you will see an issue with that. Recursion depth limit exceeded. Why this happens? When you are calling the function again and again in of infinite number of times, then the hardware reaches its limit where the stack space is filled and no new function calls can be made because the stack is filled. So in that case, you will find you will be in trouble. So that's why in recursive functions, you need to be very careful that there is a clause that makes sure that this function calls are not infinite. Fine. The number of times the function will be called by itself is not infinite. There is a finite number of calls for each function, and that is handled by the base case. So what does base case do? So as we already saw, is this visible? This is visible. As we already saw, in the base case, what is has it returns something that exits the program. So basically, no new function calls are made from this point of time, and only the values are returned from the stack space. So stack starts getting emptied as the values get returned. And the important thing is the recursive case should lead to the base case. Why it should lead to the base case? Because without reaching the base case, your program won't exit the loop of recursion. Fine. So this is how recursion works in C programming language. And the factorial is a classic example where you can use recursion. Why you can use recursion? So let's go back to the next problem. Why use recursion? So it is helpful called repeated operations on arguments of same data type again and again. Fine. For example, for factorial, if you want to compute n factorial. So let's say I want to compute factorial n. So it can be written as n multiplied by factorial n minus 1. Everyone, do you agree with this? So the factorial example is a classical example of why do we need recursive functions? Why do we when we need to use recursive function? It can be used in programs where same number of operations are being repeated for the arguments of the same data type. For example, in factorial, whenever you talk about factorial of n, it is essentially n multiplied by factorial of n minus 1. That's why you can solve this using recursion. Fine. And now this n minus 1 can be expanded as n multiplied by n minus 1 multiplied by factorial of n minus 2. And you keep doing this until you reach 1. When you reach 1, then you return 1. And then you can see you will get the factorial values. Fine. So let's say this factorial function now. Now we have the idea of how recursion works. What are the important clauses in the recursive function, and how it is useful for define writing the program for a factorial of a number. Fine. Now we have a function, recursive function factorial, with so we have a function factorial that has a return type of integer. So someone is typing something. No one has any doubt. Yeah, fine. So now we have this factorial function. Sorry. Yeah. That has a return type of integer, and it takes in an integer argument n. And so we have so we already saw we need a base case. So you can see we have a base case. If n is 0, return 1. And then we have a recursive case. Sorry, guys. So we have a base case and a recursive case. Just yeah. So in the base case, if n is 0, we return 1. So we know this, that factorial of 0 is 1. So for the base case, we return 1. Else, in the recursive case, what we return? We return n multiplied by the function factorial called again over the value n minus 1. Fine, everyone? So we can see this function completely satisfies the requirements of a recursive function. It has a base case and it has a recursive case. Fine. Now, the next thing we need to do is see how many times this function factorial will be called. So the input to our function was n equals to 5. So input is 5. So n equals to 5. So let's call this function. So we call factorial 5. So does it satisfy the base case? No, the base case is not being satisfied here. So 5 is not equals to 0. Basically 5 is not equals to 0. Then you return 5 multiplied by factorial of 5 minus 1. So this is the recursive case. So 4. Now let's see what does this function call do. Factorial of 4. So let's do this. Factorial of 4. So again 4 is not equals to 0. So it does not satisfy the base case condition. So what it returns? It returns 4 into factorial of 4 minus 1, which is 3. Fine. So now let's again see how this factorial 3 function unwraps. So factorial 3. So factorial 3 is again not equals to 0. So what it returns? It returns factorial 3 multiplied by factorial 2. Now let's see what this function do. So factorial 2 Again, 2 is not equals to 0. So what it calls, it returns 2 into factorial 1. Now let's see what does factorial 1 do. Factorial 1, factorial 1, essentially 1 is not equals to 0. So what it returns? It returns 1 into factorial 0. Now let's look at the function factorial 0. It is 0. 0 equals to 0. So what does it return? It return 1. Fine, everyone. Are you able to see this? How we started from the value 5? We tried to find the factorial of value 5, and we keep calling the function recursively until we reach the value 0, where we reach the base case. So this is basically base case. No, this is the base case. So this is our base case. So factorial 0 comes into the base case when n is equals to 0. What you have to do? You have to return 1. So it breaks the recursive call here. So eventually our function is capable of leading to a case, leading to the base case eventually. So it's for sure that our program will exit. So it will not call in, it will not result in infinite recursion. Fine. So this is how this program works. So now this value returns 1. So let's copy and paste these values here. So what is factorial 0 here? Factorial 0 is 1 basically. So we get the value 1 here. Fine. Now again, what does factorial 1 returns? Factorial 1 returns 1. So we get 1 here. Then what does factorial 2 returns? Factorial 2 returns 2 into 1, which is 2. So it returns 2 here. So what does factorial 3 returns here? Factorial 3 returns 3 into 2, which is 6. Now what does factorial 4 returns? Factorial 4 returns 4 into 6, which is 24. Then finally, what does factorial 5 returns? Factorial 5 returns 5 into 24, which is 120. Yeah, 120, which is the factorial of the number 5. Fine, everyone. Did you get how we are able to solve this factorial problem? Hello? So everyone, did you understand how we solve this problem of factorial using recursive functions? Fine, I hope no one has any doubts. So let's go back to the problem statement. So what did the program ask? It asks you how many times the function will be executed, no? So let's see how many times the function got executed. Fine. So we have one factorial call here, then the next factorial function call here, then the next function call here, then the next function call here, then factorial call here, and then finally the base case. So how many times we call the function factorial? 1, 2, 3, 4, 5, 6. So the answer is function called 6 times. Fine, everyone. Is this clear? Do you have any doubts with this program? Yeah, someone is asking me to solve this again. So yeah, I will just explain it again. So just wait a moment, guys. I need to get my mouse. So hi everyone. Apologies for the delay. So basically, I wasn't able to find the mouse for my laptop. So I'll try to use the trackpad to show you the solutions. Fine. So is my screen visible? Please confirm. I'm just solving it here only. So let me share the screen. I hope this whiteboard is visible and whatever I'm drawing on the screen. So someone is saying it is showing that I'm sharing my entire screen. So nothing is visible to you guys. So can you see this? Anything I'm drawing on the screen, is this visible? So is there, are you seeing any, let me do one thing. So just open this whiteboard. Can you do this, everyone? Everyone, can you open this link? Huh. So the whiteboard should be visible to you guys now. Anyone? Everyone, please confirm that you are able to see this whiteboard. No? Anyone? So I guess this is not working or what? So there is a whiteboard that I've shared with you guys, and I have drawn some curves onto this. If this is visible, please uh, confirm. If it's not, then everyone, this is visible. Okay, fine. So Rishi, is this visible? You typed that you were not able to see. So I guess if it is visible to a majority of the class, so every one of you should be able to see this. Fine. So what we were doing, we were solving the factorial problem. So let's call the function f for now. So because I don't have something to write, so yeah, let's see how does it work. So when I call the function f5 here, fine. So what it does is it returns the value 5 into, so 5 multiplied by the function value f4. Fine. And on the stack, so on the main memory, let's call this the main memory thing. So let's call this the main memory. Let's write the name m here. So whenever you call the function factorial f on 5, this reference gets stored on the stack memory. And then what this function does is it returns the value 5 multiplied by f4. Now you are again calling the function factorial f here. So it again gets stored onto the stack. And this function, what it does is it returns 4 into factorial of 3. Fine. Now again, this function returns what this value. It again calls the function f again. So this reference call again gets stored to this stack memory. And this f3, what does it return? It returns 3 into factorial f of 2. Now it again, this call gets stored to the memory stack. And then let's see what this fact2 does. It returns 2 multiplied by factorial call f over the value 1. Fine. Now we are again calling the function f again. So we will store it to the main memory, the reference, and then f1, what it will do? It will return the value 1 multiplied by f0. 1 multiplied by f0. So what is so again we are calling function f0 again over the argument 0. So its reference gets stored to the stack. Now what does f0 returns? This is the base case. So it returns 1 here. Fine, everyone. Is this clear? So one student asked me some doubt. Uh, I guess it was SKR Rishi. Rishi, is this clear? So this should be clear, no? Rishi, can you confirm? Is this figure clear, Rishi? Fine. So this is how this recursive function calls happen. So now what the question is asking you is asking how many times the function factorial, in this case f, is being called. So it is being called the number of times these references are being stored to the stack, and you can count this as 1, 2, 3, 4, 5, 6. So the function f is being called 6 times here. Fine, Rishi, is this clear? Yeah. And the next thing is, so function is called 6 times. Fine. The function is called 6 times, and how it returns the value. So basically reach the base case here, f0, it returns 1. So this function call returns the value 1 here. So it becomes 2 into 1, and the stack memory gets freed. Fine. So this memory gets freed, and then f2 into 1 is returned by the function f of 2. So it returns 2 here. Then again, memory is freed. Fine. Then f of 3 returns 3 into 2, which is 6 here. And this memory gets freed. Then 6 into 4 is returned by the f of 4 call here. So this memory is freed and it returns 24. And the last function call for f of 5 is returned, which is 5 into 24, which is essentially 5 factorial. 5 into 24. And the stack memory is emptied. Fine. Is this clear, everyone? Rishi, again, you are not able to see this whiteboard, Rishi? So, I mean, it is visible to most of the students. So never mind, like you can go back to the video recording of this session and you will be able to find this explanation again. Fine. So I have done this both in the document file. Yes, yes, I have sent one link. So you can go back to the session recording again and you will find this. So I think there is some issue on the network issues on your side. So please check that again. Fine. So because others can see the shared screen. Fine. And someone is asking, so there she's asking, he wants to ask a question from week 6 as assignment 6. So you may ask this question after I have started, after I have solved all the problems for this session. Fine. So Rishi, you can go back to the video recording of this session again and you will get the solution. Fine. Yeah, you could have logged in and you could have seen the whiteboard, and it is also visible here for most of us. So I guess there is some network issues by your side. Fine. Yeah. So let's get back to our problems. Fine. So the function factorial is called 6 times. So you can also say this. I hope my screen is visible. No, the screen is not visible right now. Now is this visible? Now it should be visible, everyone. Great. Yeah. So let's move on to the next question. So what is the output of the following C program? So again, we are including the standard IO library stdio.h. Then we have the function fun that returns value of integer and takes an argument n of data type integer. Fine. Now inside the function, what I'm doing, I'm declaring three integer variables I, j, and sum, and assigning the value 0 to the variable sum here. Now we have a for loop here. Just fine. So now we have this for two for loops. So for I equals to 1, I is less than n, I plus plus. So this for loop runs from I1 to n. So the n is the argument that is input. And then what is the scope of this for loop? The scope of this for loop will be the uh, uh, yeah. So the scope of this for loop will the either the function block if we have declared a function block using curly brackets, and in this case, since we don't have that function block, the scope will be just the next line. Fine. The scope will be just the next line. So the scope of this for is just the next line, which is anything in this line. Fine. Now, since you are again calling the for loop for j equals to 1, I, j is less than equals to I, j plus plus. And we are doing some operation in this block. So the scope of this top for loop, so this for loop is anything, is the scope of the next line. So what will be the scope of this next line? This will be an entire scope of this block. Fine. So this is the scope for this next for loop. So this is how this function works. Now sum, we are adding the value sum equals to sum plus j, and then finally we return the value sum. And then print percentage d func 10. So we call the function over the value 10, and then we return 0. And we have to see what the function will print. Fine, everyone. Is the explanation clear for this function? The explanation clear for this problem? So we have a function that takes an integer argument, one single integer argument as input, and returns the integer value. And then inside the function, we are declaring three integer values, I, j, and sum, and we are assigning the value 0 to sum. Then we have a for loop that runs from I equals to 1 to n. And then the nested for loop inside that for loop that runs from j equals to I to I. J equals to I, J is less than equals to I. So basically what is happen is, so when you say this, just how to stop drawing. Huh. So this loop runs only one time, only once. Why? The condition is j equals to I and j is less than equals to I. So basically this loop runs only once because of the condition. So you are assigning the value j equals to I and you have to run until j is less than equals to I. So j is already I. So on the first case, for the first execution, it will execute. And then in the next line, it will have what will become j will become I plus 1, which is not less than equals to I. So the loop will exit. So this loops only runs only once while when j is equals to I. When j equals to I. Fine. So what the sum value is doing? It is adding up the values sum equals to sum plus j and then returns sum. So what are we essentially doing? Adding the values from 1 to n. Everyone, did you get this? How it is happening? So you can see if you call it for uh, so when you look at this problem, so when you look at this function loop, you can see what it's doing. It is doing sum equals to sum plus j. So let's say sum was 0, 0 plus, let's say n was 10. So I would have been 1. So 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Because I is running from 1 to 10. So and j is basically I for each loop, each iteration of the top loop. So the values that are getting added is sum equals to sum plus I. So basically I can replace these two lines with a single line sum equals to sum plus I. Fine everyone, is this clear? Yeah, you don't need the J loop here. You can simply replace. So we can replace the above two lines with this line. So which would be sum 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 equals to sum plus I. That's it. And then it will work. Yeah, we don't need the J loop here. Fine. So what is the sum from 1 to 10? Anyone? Any guess? Option A, 55 is the answer. So you can check this using the formulas 10 into n plus 1 divided by 2. So it's a standard formula for adding up values, series values from 1 to 10. Fine, everyone. Do you have any doubts in this program? Anyone, if you have any doubts, please type in the chat box. Fine. If you have any doubts, please type in the chat box. I guess no one has any doubts. So let's proceed to the next question. So which of the following statements is correct? A function with the just a minute. Huh. Huh. A function with the same name cannot have different signatures. cannot have different return types, have different number of. Hmm. Hmm. So which of the following statements is correct? A function with the same name cannot have different signatures. So that is true. So by signature, we mean the function so what is the return type? What is the input arguments? Fine. A function with the same name cannot have different return types. That is true. A function with the same name cannot have different number of parameters. That's true. So the correct answer is option D. D mentioned. Fine, everyone. Do you have any doubts with this problem? So this is straightforward objective question. So what is true? What is allowed for function in C? So they can they cannot have same name and different signatures, different number of return types, different return types, and different number of parameters. Fine. So what is the signature? So signature of function is like the function. So we already saw this function prototype, no? So the function signature is basically the function return type and the set of arguments it can take. Is this clear, Yashwant? So the set of function name, return type, function name, return type, and the arguments. These three set combined make up the function signature. Is this clear, Yashwant? Fine. So anyone else, do you have any doubts in this problem? Just type in the chat box. Fine. So let's move on to the next question. So what will this function return? So we have integer func int(x), int(y). So this is the function name func. This is the return type integer, and these are the arguments x and y, both belongs to data type integer. So these three things make up the function signature here. So what will the function return? If y equals to 0, return 0. If y equals to 1, return x. Else return x plus func x comma y minus 1. Fine. So it is a recursive function. So we have all these cases. So these two form of the base case. So these are the base cases. And this one is the recursive one. Fine. So this is a recursive case, and this is the base case. So it satisfies the requirements for a recursive function. So what is the function doing? Fine. So let's start solving this. So let's take some arbitrary n. So let's say n equals to 10. Oh, sorry. So let's take x equals to 4 and y equals to 5. And let's see what the function does. So we have func x 4 comma 5. So none of the base cases are true. What it will do? It will return 4 plus func of 4 comma y minus 1, which is 4. So now what this recursive func call will do? Func of 4 comma 4 returns 4 plus func of 4 comma 3. So what is func of 4 comma 3? 4 comma 3 returns plus func of 4 comma 2. So what is func of 4 comma 2 returns? It returns func of 4 comma 1, which returns, so this func of 4 comma 2 returns 4 plus func of 4 comma 1, which returns y equals to 1. We have to return 1, so it returns 4. Fine. So basically what our function is returning here, it returns 4 plus 4. So it returns here 4 plus 4. Then what this function returns, it returns 4 comma 3. 4 comma 3 returns 4 plus 4 plus 4. And then 4 comma 4 returns 4 plus 4 plus 4 plus 4. And then 4 comma 5 returns 4 plus 4, 4, 4 plus 4 plus 4 plus 4 plus 4. Fine. So what is essentially it does? It does 4 into 5. So what this function is doing is basically returning the value of x how many times, x plus x how many times, the number of times y is. So basically x into y. It returns x into y. So option B is correct. Option B. Huh. So yeah, why option B? Because x and y cannot be any integer if x and y are negative. So this function will so what happens if x and y is negative? Anyone? What happens if x and y are negative integers? Hello? So yeah, you are right. So what it does is it returns x summed upon number of times y. The variable y contains the integer value. So for example, if y is n, so it returns x plus x n times. So basically x into n. Fine. So this is true. The question is what happens if x and y are negative? Anyone? Can you answer this? So what if I pass in minus 4 comma 2? Minus 4 comma minus 2. Anyone? What if I pass 4 comma minus 2? No one is answering. Am I audible? Wow. Anyone, please answer. What happens if I pass 4 comma minus 2? So what if y is negative? Yeah, that's true. It will go into the infinite loop. Why? Because none of the base cases considers the case where y is negative. None of these base cases consider what happens if y is negative. So this is infinite recursion. If y is less than 0. Fine. So how there are a few things how to solve this. First thing is why it is returning x into y when y is non-negative. Because if y is 0, you are returning 0. So any number multiplied by 0, you get 0. Else if y is 1, you are returning x. What does this mean? Any number multiplied by 1 is essentially the number x itself. Now else what you have to do, you have to return x plus x summed number of times y minus 1. So basically x plus y minus 1 into x. So which is basically x into y. Fine. So how to correct this? Let's say if I want to accommodate for the case where the values of y is negative, what can we do? Anyone? Anyone, can you suggest a way? What should be done if y is negative? How to resolve this? So for y, if y is negative, what we can do? We can create another case. If y is less than 0, what you can do? You can return minus of x plus func x comma y plus modulo y plus 1. That's it. Modulo of y plus 1. Then it will do it. Because what it will do? It will do the positive multiplication only, but with a negative sign. Fine. Everyone, did you get that? What I'm saying? So try this on your own as a homework problem. So what you, if I want to ensure that this y is to ensure that this function works for negative values of y also, for y taking up the values of negative integers, then what to do? Fine. Let's move on to the next question. Anyone, do you have any doubts other than the last case where I said what happens if y is negative? Anyone? If you have any doubts, this is the right time to ask the question. Great. So let's move on to the next question. So what is the output of the following C program? So again, we have a standard IO library. So we have the function fun that takes in an integer argument n. So this is the input argument n, and it returns integer values. Fine. Now we have integers I, j, and sum. So we have the integers I, j, and sum. Sum is assigned to the value 0. So it was the same function we already saw. This is 5 into 6 by 250. The answer is C, option C. Everyone, do you get this? How this function works? No one has any doubts in this problem? It's the same question as question number 3. So same as question number 3. So I hope you get the answer. Same as question 3. Option C. Option C is correct answer for this. Fine. So I hope question number 3 is clear to everyone. So let's move on to the next question. So what will be the output of this function? So we have included the standard IO library. Fine. And we are declaring a function void swap. So what are the inputs? The inputs are two integers, integer A and integer B, and it returns a void value, no value. It returns nothing. Then we are simply doing int temp equals to A. So we are declaring variable A, temp equals to A equals to B, B equals to temp. So if you remember the initial tutorial sessions where I solved problems on how to swap two numbers using a third variable. So this is the same problem. So what it's doing is just a second. So what it's doing is swap two variables, value and two variables using a third variable. Fine. So this is all this function is doing right now. Now let's see what our program asks. What is the question? So what is the output of this program? So we have the main function. So we all know that whenever we want to see some outputs, we need the main function. We need to see what it's doing. So we have this main function. Fine. So we need to see what the main function does. It is declaring two variables, num1 equals to 10, num2 equals to 20. Both of these belong to the integer data type. Now we have to print the values before swapping num1 equals to num2 equals to and pass in the value num1 and num2. So num1 equals to percentage %d, num2. So yeah, let me do one thing. So let's, yeah. So num1 is essentially printing the value stored in the variable num1 here. And then num2 is printing the value num2 here. Now what we are doing, we are making a function call. So we are calling the function swap over the numbers num1 and num2. And again, after this function is called, we are again printing the value of variable num1 here and the value of num2 here. And it's saying the values after swapping are this. Fine. So the initial values were 10 and 20. So anyone, can you answer this? Can you guess this? So for now, just believe that the swap function, what it's doing, it has some code that swaps the value of the stored in the two arguments passed in as input, and it returns nothing. So someone is saying no swap. That's perfectly correct. Why there is no swap here? We will be looking into this. First, let's get to the answer. So the correct answer is, so before swapping, the values were 10 and 20. After swapping, the values has to be 10 and 20. So option A is correct. Now let's get to the reason uh, why this is happening. So Veda, someone is saying that my voice is not audible. Is this true for everyone? Please confirm. Is my voice not audible for everyone? Is this audible? So I guess there is some a network issue on your side, Veda. Please look into this. Yeah. So why does this function not work? Anyone, can you tell me why? What is happening? So are you familiar with the idea of call by value and call by reference? What does these two terms mean? In when we talk about functions in the C programming language? So yeah, someone is correct. Someone is Yashwant is saying call by value done there. So basically, there are two ways that are followed when you pass values to functions. The first one is call by value, and the second one is call by reference. So let's look into the differences. Why? Because the function swap was called using call by value protocol. So what are these two protocols? Let's dig deeper into these. So what is call by value versus call by reference? Fine. So we have by value. Fine. So what is call by value? passes a copy of the value stored in value passed contained by variable to the function argument. What is called a pass? It passes a reference to the variable passed as input to the function argument. Fine. The changes inside the function do not get reflected in the callee function. So what is callee? Callee is basically the function where you are calling the function. Changes are reflected. Function that calls another function and the called function. Fine. So how to use this? So let's say we have a function. So you simply call variable here, and in call by reference, you pass the address of the variable back here. So this is how you do call by reference and call by value. Fine, everyone. Are these differences clear? So basically what happens in call by value. So whenever you pass this values num1 and num2 this swap function, a copy of those values are passed to the function swap and some operations are done. So wherever if you change the values stored in the variables a and b in this function, nothing happens inside the main function. Now let's say it was a call by reference function. Then what would happen? Then the values would have been reflected. So how to do so? So let me just do that here itself. So let's make some changes and make it a call by reference. So first change would be in the function reference, a function declaration itself. So function signature itself. So int m percent a int percentage a. So you basically pass the pointer to the address of the pointers. Fine. And now inside the function, okay, let me bring it, make it. So inside the function, now what you have to do? This is the new function I'm writing for this pointers. M equals to the value stored in variable A, the value stored in A equals to value stored in B. So you all know, acha, you don't know the idea of pointers right now. So yeah, you will, and value stored in B equals to 10. So now what will happen? It will simply swap the value stored in the variables A and B. And how I will change this line? So let me change this function call also. So instead of simply calling the function swap here, you will call the function ampersand num1 and ampersand num2. So you are basically passing the address of these two variables. This is how you will replace this function with a function call by reference. Fine, everyone. Is this clear? So what are these pointers here? Let's not get too much deep into this. Let's not get too much involved into these pointers right now. You will be have some problems sessions later on for these pointers. So for now, just understand that these pointer variables are used to store the address of the variables where the values are stored. And since we are using integer variables, so we in the function we are so yeah, where was it? Yeah, so in the function we are using int asterisk a and int asterisk b. What it means is the values that we are going to receive will be a pointer to the some integer value data type. So it will it will show the it will contain the address of some variable of that of data type. Now, what is asterisk a here means? So these all asterisk a are pointer dereferencing. So what they do is they give you the value stored at the memory location pointed by that pointer. Fine, everyone. Hello, everyone. Is this clear? Is this distinction clear between call by the value and call by reference, everyone? Anyone, do you have any doubts? Please type in the chat box. So now if I run the program using this new function and the new function call, you will see that the value will be swapped. So let's not get too much into this pointers right now. Fine. Anyone, do you have any doubts? Please type in the chat box. Anyone, if you have any doubts, please type in the chat box. I guess no one has any doubt. So let's move on to the next question. Yeah, so I hope this is clear. So let's move on to the last question for this session, and then I'll be taking problems from you guys, doubts from you guys. So let's go again, go back, see another problem. So we have a function variable Fibonacci. So we have a new function. Let's see, which returns an integer data value. The name is Fibonacci and take one input argument int. And inside the function, I'm using switch cases. So I'm switching to the variable n here. So let's switch to the variable n here. Now we have this default case. So everyone, are you familiar with the switch cases in C? So the default case is the case which gets executed when none of the cases is true. So what does default case say? It returns Fibonacci n minus 1 plus Fibonacci n minus 2 by default. And then we have case 1 that does nothing. It does not even have a break statement. Then case 2, it again does nothing and it does not have a break statement. And finally, what our program does is it returns the value 1. If this switch case construct exits. Fine, everyone. Is the function clear to you? So I hope by now I hope that I can assume that you all are familiar with the switch case statements in C. So whenever I'm calling switch and here, so this what is it is doing? It is switching to the value. So now stored in the variable n. So now let's say n contains the value 1 or 2. What the switch case to statement would do? It would do nothing. Fine. And why it would do nothing? Because there is nothing beneath this switch case statements. Now, otherwise, if this is the default case, then what would happen? What is the meaning of default case? If n is neither 1 nor 2, then what it would do? It would return the value Fibonacci of n minus 1 plus Fibonacci of n minus 2. So function will exit by calling the function at the values n minus 1 and n minus 2 and returning their sum again. Now, what does the question say? The function above has a flaw that may result in serious error during some invocations. Which one of the following describes the deficiency illustrated above? Fine. So for some value of n, the environment will almost certainly exhaust its stack space before the calculation completes. An error in the algorithm causes the unbounded recursion for all values of n. No, so there is no it will not call unbounded recursion for all values on n. For sure, option B is not correct. Option C, a break statement should be inserted after each case. Fall through is not desirable here. Yeah, that maybe, but it's not a big issue right now. And we don't need the break statement essentially because for cases 1 and 2, we are doing nothing, just returning 1. Fine, everyone. For cases 1 and 2, we are doing nothing, just returning 1. And for the default case, we are already using the state return function, which essentially exits the function itself. So we don't need the break statements here. So option C is not correct. So the option D, the Fibonacci function includes calls to itself. This is not directly supported by standard C code due to unreliability. No, this is false. Fibonacci function includes call to itself. This is perfectly allowed in C, and this is what is this function is an example of a recursive function. We already saw recursion here. So this is option D is also not correct. So the last option that is true is option A. For some values of n, the environment will almost certainly exhaust its stack space before the calculation completes. So yeah, that's true. Why this is true? Because if n is very large, then it will basically exhaust the stack space. Yeah, that's true. Because you can see we have the default case. So if n is not 1 nor 2, neither 1 nor 2, then what it happens, it goes to the recursive case. So so these two are cases 1 and 2 are base cases. So let me do this here. So these two are base cases. So these are base. This is a recursive function. These two are base cases, and this one default case is the recursive case. Now if the value of n is very large, then the stack space will be exhausted. This is the recursive case. Fine, everyone. Is this clear? So yeah, someone is asking me to explain the NPTEL exam pattern. I don't know because this is I'm not responsible for those duties. So you can ask the NPTEL team for this. Fine. Anyone else? Do you have any doubts? So the program is fine, but yeah, if n is very large, then it will exhaust the stack space. That's the correct answer for this. Anyone, do you have any doubts for this problem? Please confirm by typing in the chat box. So Yashwant, I'm not I cannot answer your question because I'm not the right person to contact for these queries. You can ask the NPTEL team for this. Yeah. So anyone, do you have any doubts? So let's take a break for 10 minutes. And by the break, what I mean is I'll be online here itself. And I don't have any more questions for you guys to solve. So for two more questions to solve. So if you have any queries, please type in the chat box. So you can ask questions for any topics that are covered till today. Someone has saying that they had some doubts from the assignment 6. So you can ask that here itself, and I will answer your queries. And so you can ask your queries by typing in the chat box. Fine. Yeah, someone is asking a question related to insertion sort. I have a question for this. Is this been taught to you guys? Have you have you seen insertion sort in the video tutorials right now? I mean, till week 8. Is this topic has this topic been covered to you? So it's in week 9, no? So yeah, I can't answer this right now because this might be in your assignment problem. So I won't be able to answer it right now. Fine. So I won't. I will only answer questions for the topics that are covered till week 8. So if you have any doubts, please type in the chat box. You can ask your queries for the topics that are covered till week 8. So no, you cannot return multiple values from a function at a time in C. So you can return a function. You can return a pointer containing the starting address of some value, some array, and use that to return multiple values. But you can't return multiple values on a function at a time directly in C. There are ways to do this, but you by default you can't do this. So if as you will see understands some more get into details on more of pointers, then you will see that you can really use pointers are how powerful pointers are, and you can really use them to do these tasks like returning multiple values from a function or like doing other stuffs that you can't do directly using static arrays or data types. So I guess this is a problem for this week. I can't solve this also. So yeah, I will give a hint for this problem. Whoever has asked this question, I can give a hint for this problem. I won't be solving it completely for you guys because I'm not sure if this is asked in this week's assignment problem or not. But yet again, I will give a hint. Fine. So this is the problem, everyone. Please see. So if we have an integer data type A, then we have ARR5, an array containing 5 values, 5 integer values, which are 1, 2, 3, 4, 5. And we are saying ARR at 1 equals to plus plus ARR at 1. Fine. And then A equals to ARR at 1, ARR array at 1 plus plus. And then ARR at 1 is array at A plus plus. And then you have, this is a pretty basic problem. I hope you will be able to answer it on your own. So let me give you a hint on this. So the value being assigned to the value ARR at 1, so index 1. So what is the value at index 1 in the array, which is 2. Now that value is being replaced with a value plus plus ARR at 1. So plus plus 2. Just replace ARR at 1 with 2 here. So you will see ARR at 1 equals to prefix increment of ARR at 1, which is prefix increment of 2. And by prefix, what we say? We say use the value and then change it from the next line. Fine. So I hope this answers your query. And then A equals to ARR at 1 plus plus. So now you have some value stored at the index 1 in the array ARR, and you are using postfix increment. And then lastly, ARR at 1 equals to ARR at A plus plus. So now what is A? A contains some value, and you are using postfix increment to it, and you are accessing that index to in the ARR to assign the value at the ARR array at 1. So again, you can use the ideas of prefix and postfix notation operations to solve this problem. Fine. It's a 6-week problem. So yeah, that's straightforward. So let's solve this. So let me do one thing. Let me share my entire screen. No, let me share a whiteboard. So now, Veda, is this clear? Is this visible? The whiteboard is visible. Please confirm. So I am not writing the entire program here, but I am just doing. Okay. One equals to plus plus ARR at 1. Then A equals to ARR at 1 plus plus. So Veda, please confirm if my whiteboard is visible. If it not, then there is some issue. Otherwise, I'm solving this problem. So whatever I'm writing here should be visible to you. So is this is not visible? Whiteboard is not visible? Veda, please confirm, because this is a question asked by you itself. So whiteboard should be visible. So I can see multiple students joining. Yeah, now great. So now let's solve this. So what does this mean? Prefix increment means change the value, then use. So ARR at 1 is plus plus ARR at 1. So the value that we are interested in is in the index 1, which is 2 here. So ARR at 1 becomes 2 plus 1, 3 here. Fine. So just interrupt me whenever you lose the track of the solution. Now A equals to ARR at 1 plus 1 plus plus. So use the value and then change the value. So what is the value ARR at 1? ARR at 1 is 3. So the value becomes 3 here. A becomes 3 and ARR at 1 becomes 3 plus 1, 4 here. Now ARR at 1 equals to, sorry, ARR at 1 becomes ARR at A plus plus. So use then change the value of A. The value of A is 3. So 3. So which is equals to 1, 2, 0, 1, 2, 3. ARR at 1 becomes 4. And then you print the values of A and ARR. So A becomes 3 plus 1, 4. And A. So 4 comma 4. Is this correct? Or I'm doing something wrong here? Option C is correct. Veda, is this correct? Can you confirm? So I have solved this problem. So I'm doing something wrong here. So Yashwant, can you explain where I am doing this mistake? 3. So A was 3 here. A plus plus A becomes 5. Okay. Okay. So let me do one thing. Let me just solve this. And let's see. Mm, so yeah, I'm just cross verifying by solving this problem using this, compiling this problem and see what is the output. So error one equals to error at e plus plus. I think it is correct. Error one plus plus error at one. One plus plus error at one. No, I'm right. It is 4, 4, 4. Yeah, it is 4, 4. Yeah, yeah, yeah. That's what I'm saying. So Veda, is this clear? So I've cross-checked it. It's correct. It is 4, 4. Yeah. Anyone else? Do you have any doubts? Please type in the chat box. So anyone else? If you have any doubt, please type in the chat box. Okay, guys, if you have, if no one has any doubts, we can end the session. So should I end the session? If no one has any doubts, please confirm. Great. So thank you all. So let's see you next week. Fine.